Okay, so what we're going to talk about now is we're going to continue solving systems of equations, except if you remember, in the earlier sections, we were solving systems of linear equations. So now we're going to talk about, well, we're solving these equations that are nonlinear, so how do they look? So before we do that, let's just quickly specify what the goal is. So the goal of this section is to use substitution, elimination, and the graphical method to solve systems of nonlinear equations. So what we're basically going to get into here is that you'll notice that the process, substitution, elimination, and graphical, we're not going to really talk about examples of the graphical method. I mean, the graphical method, we already know that you would need to graph this on maybe some graphing utility, and then all you need to do is find the point of intersection. But we're mainly going to focus on the algebraic approach, which is through substitution elimination. But these methods that we're talking about isn't any different than the methods we used in the linear equation. So it's not like all of a sudden we're reinventing the wheel here and saying, look, now for the nonlinear, we're going to do these differently. It's still the same thing. Except there will be one minor difference, and we will talk about that momentarily. So let's talk about what a system of nonlinear equations are defined as. So systems of nonlinear equations are defined as two or more equations where at least one equation is not linear. So we're saying it's not that we can't have linear equations. We're saying one of them has to be nonlinear. So what do we mean by nonlinear? Well, obviously, if you're to graph it, the graph does not resemble a line. Okay. So for example, if we have something like the form of x plus y equals to 3, x squared plus 2y equals to 12. So why does this become nonlinear? It's because of this guy, right? If we were to graph this, we'd notice that this would be a parabola, which is clearly non-linear. So just because of this one equation, see, this one is linear, which is fine, but this is what makes it nonlinear. Okay, so just keep that in mind. Not all the equations must be nonlinear. As long as one of them is nonlinear, then this becomes the nonlinear case. Okay, so the methods we will use, as mentioned earlier, is similar. So the methods we will use are similar to that of the linear case. Okay, so that is, one would be substitution. That's one method. Two, the second method would be elimination. Now, I want to make a comment on the elimination. We can't always use elimination. Okay, so when could we use elimination? As long as the variables are like variables. So what am I saying here? As long as we have two of the same variables with the same exact powers. So for example, so if they're like variables, we can then use elimination. So one example I want to show you guys where you'll notice that elimination won't work is something like this. For example, if I give you something along the lines of x plus y equals to 3 and x squared plus 2y squared equals to 1, what is it that we notice here? I cannot use elimination because this is x, that's x squared, that's y, that's 2y squared, or that more importantly, the 2 doesn't matter, it's just this is y, that's y squared. So I can't really eliminate these guys using the elimination method, so we're better off for this using substitution. So just keep in mind that for this, we cannot use elimination. Okay. So one other comment I want to make, and as we're kind of going through this, you'll see that when we do some examples, you'll see, hey, this one we can use elimination, and then the other one maybe we're better off using substitution. So we'll see some examples where it'll be evident or it'll be obvious as to which one would be a better approach to take. And then of course the third approach is the graphical method, where we can graph and then we'll see exactly where the point or the curves intersect, and every time they intersect each other, that's the solution. Okay, so one other comment I want to make for the nonlinear cases, and you're going to notice that this becomes a common theme, so expect to solve by factoring when dealing with systems of nonlinear equations. So I'm not saying that you're always going to factor, but more often than not, you will probably do some kind of factoring when you're solving this, okay? That's because if I have kind of like x squared, x cubed, and so on, and you know, we solve those if we have multiple variables. We could solve those through factoring, but that's not always the case, right? And in fact, you know, if we could avoid factoring, which if things break down and it becomes much easier to simplify, then we don't need to factor. But you'll notice that that's going to be the case here. So one last comment I want to make is this. If you remember for the linear case, it was either we had one solution, no solution, or infinitely many solutions, right? Now, for the nonlinear case, we don't always have to have one solution, no solution, infinitely many. I mean, those are possibilities. But since now curves are nonlinear, see, we can have various outcomes, various possibilities. That's why when we're solving these, we need to find multiple solutions. Like, for example, in this case, like here are some examples where some possible solutions we can get out of it. So if I have some possible solutions in this case, what could we get? We can have, for example, a parabola and a line, for instance. And what is it that let me move this up so we could see it. So what is it that we notice? See, these have two solutions. How come? Because the parabola and the line intersect in two places. So this is two solutions. We could still have one solution if, let's say, we have a parabola and a line of that form. Like, see, once again, that's one solution. Or we could have no solution, where what if the line is kind of below the parabola like that, so we could see once again they don't intersect, so this is no solution. But see, the example I used here is only strictly what between a parabola and a line. We could also have circles, we could have like different types of shapes once it becomes nonlinear. So, or we could have something like this where we have a downward parabola and we have an upward parabola, for instance, and that gives us two solutions again. Or we could have maybe a circle and a parabola that goes up like this, which now what do you notice here? This has what? 1, 2, 3, 4 solutions. So what I'm basically telling you is, for the nonlinear case, we could have more than one solution, and less than infinite, or we could have like 4 or 3 or whatever it may be. So our goal is just to try to find all the possible solutions, if any. Okay. And also it could be infinitely many. So that's kind of the one comment I want to make about the solutions. But with that said, now let's kind of start doing some examples, and then that will basically take care of this section. So for example 1, we're saying find all solutions of the system x squared plus y squared equals to 625, and what else? 3x minus y equals to negative 25. So right away, what is it that we notice here? I don't want to use elimination because I don't see my variables that are the same. Like this is x, that's x squared, that's y squared, that's y. So what's the better approach? Probably using substitution. Now when I'm using substitution, I would rather grab this and solve for y. Right? So if I take that and solve for y, what does that become? So if I just do this really quick, what would that be? Y equals to 3x plus 25. So all I did was I grabbed this and I solved for y. So that's what that you get there. Okay, so if you want to kind of do the steps to verify that, feel free to do so. So once we have this, now I could come back up and replace y with 3x plus 25. So if I do that, now taking this upper equation, I have x squared plus 3x plus 25 quantity squared. So what did I do here? I just replaced the y with 3x plus 25 equals to 625. So now we're going to solve by simplifying. So let's square this out. So what does that give me? X squared plus 9x squared. 3x times 25 is 75x, and that's going to be doubled up. So what would that be? It'll be 150x plus 25 times 25 is 625 equals to 625. And how nice is that? When I subtract the 625s, that'll go away. So what do I have here? X squared plus 9x squared, that's 10x squared plus 150x equals to 0. Right? So hopefully you follow what I did from here to here. Okay, I just simplified and then the 625's canceled out. So now you notice to solve this, we solve by factoring, as mentioned earlier. We kind of expected something like that. It's not difficult level of factoring, but we would still need to factor this. So if I factor out a 10x, I'll get x plus 15. Now, some of you might say, well, why don't you just divide by 10x? Here's the problem. If I divided both sides by 10x, what would happen? Since there's a 0 here, this 10x would completely vanish, and I'll just get that. And what would that mean? I would get only one solution where the 10x would go away, but the 10x itself has a solution, because what are my solutions? If I set 10x equal to 0, what does that mean? X equals to 0. Or if I set the x plus 15 equals to 0, x equals negative 15. So you never want to divide and get rid of variables, because when you do that, you're eliminating solutions, right? So if you were to divide both sides by 10x, you would miss out on that, and you'd think that you only have x equals negative 15 as a solution, but x equals 0 is also a solution. So remember that anytime you divide by variables and the variables vanish, that's not a good thing, right? Because you may be potentially getting rid of solutions. Okay? So since x equals 0 and x equals negative 15 are the two solutions, now we need to find their y values. And what's the easiest one to use? Well, right there, because we know y is 3x plus 25. So if x is 0, what does y become? 3 times 0 is 0, y is 25. So my first point is 0 comma 25. That's one solution. And then when x is negative 15, what does that become? Y is 3 times negative 15 plus 25. 3 times negative 15 is what? Negative 45 plus 25 is negative 20. So my second solution is negative 15 comma negative 20. So actually for this case we ended up getting two solutions. Okay, so moving on to the second example. Find all solutions of 3x squared plus 5y equals to negative 3, and then 4x squared plus 3y equals to 18. Okay, so for this, see, what is it that we noticed? This is x squared, that's x squared, this is y, this is y. So I could use elimination if I'd like, okay? So, and it doesn't matter which one you eliminate, right? So, for instance, I'm going to choose to eliminate the x's. So if I choose to eliminate the x squareds, I need to make these guys opposites. So what am I going to do? Grab that row, multiply it by -4. Grab this row, multiply it by 3. Okay, now the reason why I multiplied this by -4 and that by 3 is because I want them to be opposites. And if I do that, what do I get? I get -12x squared minus 20y equals to 12. And then what happens to the bottom one? I'll get 12x squared plus 9y equals to 3 times 18 is what? 54. Okay? So now what do? I could add them, and when I add them, notice how this will eliminate. So we can use elimination. And when I add them, I'm left with what? -11y is equal to 12 plus 54 is 66. And if I divide both sides by -11, I get y equals to -6. Okay, now that I got y is -6, I could come back to this original equations and substitute, right? So in any one of the two. So I could, let's grab this first one. And what are we doing? We're replacing y with -6, and then we can solve for x. And it looks like we're going to get two solutions out of this, right? Because of the x squared. So what does that become? 3x squared plus 5 times -6 equals to -3. So all I did is I took this equation and replaced y with -6. Now let's solve for x. We get 3x squared minus 30 equals to -3. And if I add 30, what do I get? I get 3x squared equals to 27. Divide by 3, we get x squared equals to 9. And then you square root it. What does that give me? X equals to plus or minus 3. Okay, so notice how I did get two solutions. What's my first solution? When x is positive 3, y is -6. And then my second solution is when x is -3, y is -6. Okay. Now, granted, if you chose to eliminate the y's instead of the x, you would be still fine, because then what would you be doing first? You'd be solving for x first, and then you'd get x is plus or minus 3, and then when you plugged in positive 3 and -3 in here, you would have noticed that y would have always been -6. So it doesn't matter which way you solve this. Both approaches would be just fine. Okay. So the last example I want to do, which you might want to pause this video and solve it yourself first, just for practice. I think that would be a good idea. And then and then you could play the video and then see if it matches up. But you should definitely be able to do this. So this is just an extra example for you to kind of work with. So find all solutions of x squared minus y equals to 1, and then 3x minus y equals to -3. So once again, if you look at this, what you notice is you could use either substitution or elimination. How come? Not because you could eliminate these guys, but you could eliminate these guys. So that would, for me, I think the easier way would be elimination. So what would I do? I would just say take the first row, subtract the second row from it. So what would I get? X squared minus 3x, and then the -y plus y will cancel out, equals to 1 minus -3, which becomes 1 plus 3, that's 4. And what do you notice here? Well, I have something of quadratic form, which means I'm going to solve this by factoring. So I'll move the 4 over to the other side. And now let's factor this. So what does that factor to? That factors to x minus 4, x plus 1 equals to 0. And what does that give me? My two solutions are x equals to 4 or x equals to -1. Okay, so now with that said, what could we do here? We could come up here and pick any of these two equations and plug in 4 for x and -1 for x, and then solve for y. So I'm going to take the second equation. So if x is 4, what do I get? 3 times 4 minus y equals to -3. And if you solve for this, what do we get? 12 minus y equals to -3. And y would be what? 15, I believe. Okay, so the first solution is 4 comma 15. Okay, and then what would my second solution be? It would be when x is -1, it will be 3 times -1 minus y equals to -3. and if that's negative 3 minus y equals to negative 3, and then if I add 3 I get y equals to 0. Okay, so the second solution is negative 1 comma 0. Okay, so with that said, we got two solutions out of this, and that's basically it. Okay, so notice how the approach that we took with this section is similar to what we did with the linear case, except we might get more than one solution, which notice we did in this case. Now I know we didn't do any examples of no solution, but hopefully you would notice that when you try to solve for it, you'd get something that makes no sense. Okay, so like 0 equals to 1 or something. So that basically takes care of this section. As always, if you have questions, don't hesitate to reach out to me and I'll be more than happy to help you out.